The question says that a company manufactures two types of stereo systems M and N. Each unit of system M requires 3 worker hours for process A and 2 worker hours for process B, while each unit of system N requires 4 worker hours for process A and 6 worker hours for process B. So we can actually summarize the first paragraph's information as there are two products M and N, and there are two processes, process A and process B. Reading again, it says each unit of system M requires 3 worker hours for process A and 2 worker hours for process B, while each unit of system N requires 4 worker hours for process A and 6 worker hours for process B. So this is how we can summarize our first paragraph's information. In the second paragraph, it says that the total available skilled labor hours allows for a maximum of 480 worker hours per week for process number A. So we know that the total hours for process A are 480 and 540 worker hours per week for process number B, and total hours for process B are 540. To produce M and N, we need 3 hours in process A for M and 4 hours in process A for N, and they cannot cross 480. They can be less than that but cannot be greater than that. Likewise, in process B, M needs 2 hours, N needs 6 hours, and they can at maximum be 540 hours. How many units of each type of stereo systems may be produced to maximize the profit if the profit on each unit of M and M is 2000 and 5000 respectively? So our objective function should be profit is equals to 2000 M plus 5000 N. 1 unit of M gives us a profit of 2000 multiplied by units of M will calculate the total profit from product M. Likewise, 1 unit of N gives us a profit of 5000. If we produce N units of N, we will get a total profit of 5000 into N, and adding both of them together will give us company's entire profit or total profit of the company. So this is called our objective function. If we see the questions, it wants us to tell us the number of units that we should produce to maximize the profits. We have two constraints. Constraint number 1 is for process A, which is 3. Let's represent product M by X and N by Y. So we will have 3X plus 4Y is less than or is equals to 480, and 2x plus 6y is less than or is equals to 540. We also have an objective function which is P is equals to 2000 M plus 5000 N. Now if we solve this question, we will have to draw the graph firstly. And yes, one thing to note is that we can have two more constraints, which is x is greater than is equals to 0 and y is greater than or is equals to 0. The logic behind this is that the production of M and N cannot be negative. Since they are units cannot be -1, -2, -3. If I produce M, I will have 1, 2, 3, 4, 5 units of M or more than that. If I do not produce M, I will have 0 units of M. Therefore M cannot be negative. Likewise, N cannot be negative. If I do not produce N, I will have 0 N's, and if I produce them, I can have 1, 2, 3, 4, 5 N's. Drawing the graph, I know that it will lie in the first quadrant because in first quadrant both X and Y are positive. Now the first equation is 3x plus 4y is less than or is equals to 480. If we assume that x is 0, y will be 480 divided by 4, and 480 divided by 4 gives us a value of, if we divide 480 by 4, it will give us a value of 120. So one of our points will be 0, 120. Second point, if we put y is equals to 0, 3x will be equal to 480 and x will be 480 divided by 3, which is equivalent to 160. So our point will be 160, 0, and these 2 points will be 160 and 120. The second equation is 2x plus 6y is less than or is equal to 540. Well, if x is equal to 0 for the second equation, 6y will be equal to 540 and y will be equal to 540 divided by 6, which is equal to 90. So one of our points will be 0, 90. And what about the second point? The second point, if I put y is equals to 0, 2x will be equal to 540 and therefore x will be equal to 540 divided by 2, which is 270. So second point will be 270, 0. Drawing this on our graph, we will have 270 somewhere over here and we will have y 90, 0, 90 somewhere here. So this will be our second line, and as discussed previously, feasible region is a region which satisfies all inequalities simultaneously. Therefore our feasible region will be this one. This is our feasible region. Now using the corner point theorem, maximum profit will be at the corner of this feasible region. The corners of this feasible region are number 1 here. Let's say this is A and the coordinates of A are 0, 90, or it can be this one. Let's say this is B and the coordinates of B will be 160, 0, and lastly it can be over here. Let's say this is C and C is a point from where both of these lines actually cross each other. So to know the coordinates of C, we will have to simultaneously solve both the equations. To know the coordinates of any point on a graph paper, you solve both the lines passing from that point simultaneously. So the equation of both of these lines are, the first line has an equation of 3x plus 4y is equals to 480, which can be rewritten as 3x is equals to 480 minus 4y, and it can be rewritten as x is equals to 480 minus 4y upon 3. We can substitute it in our second equation, which was 2x plus 6y is equals to 540, and we can write 2 multiplied by 480 minus 4y upon 3 plus 6y is equals to 540. 2 into 480 is 960 minus 4 into 2 is 8y divided by 3 plus 6y is equals to 540. Multiplying all the terms by 3, we will have 960 minus 8y plus 6 into 3 is 18 is equals to 540 into 3 is equivalent to 1620, and after that we will have 10y is equals to 1620 minus 960. 10y is equals to 1620 minus 960, which is 660, and therefore y is equals to 66. Once we get y, we can substitute this y into this equation and get the value of x, x is equals to 480 minus 4 into 66 divided by 3. So x is equals to 4 into 66 is 264. 480 minus 264 divided by 3 is equivalent to 72. So the last, or the point C, will have coordinates of 72, 66. Now that we have found all the coordinates and we know the profit maximization objective function, we can substitute it one by one and identify the point where our profit will be maximized. Our profit maximization function P is equals to 2000 x plus 5000 y, and at point A has coordinates of 0, 90. Point A has coordinates of 0, 90, which means we can produce 0 units of x and 90 units of y. We will have P is equals to 2000 into 0 plus 5000 into 90, and the answer will be 450,000. At second point, or point number B, our point number B has coordinates of 160, 0. 160, 0. At 160, 0, our P will be 2000 into 160 plus 5000 into 0, and therefore this will be 320,000. C coordinate has 72, 62, and our P will be 2000 into 72 plus 5000 into 66, and this equals to 474,000. So to maximize profit, we must produce 72 M's and 66 N's. At this level, our profit is maximum as calculated from corner point theorem.